All right, so let's test another claim about a mean. All right, now what's going to be different in this case is we know sigma. Okay, we know sigma. So let's talk about the topic first. So we're going to talk about adult sleep. How much do adults sleep on average per night? Okay, and so somehow we know, maybe through historical records, that the standard deviation for adult sleep, the population standard deviation, is 1.99. Okay? Now, what's significant about knowing sigma is this. When we do our test statistic will be a z-score as opposed to a t-score when we don't know. All right? And so let's look at the situation. The claim is this, that the average that an adult sleeps each night is 7 hours. But we think it's less than 7 hours. So what do? We go out and gather our data. We gather our own data. We say, okay, we talked to 12 people, and we found that their average was 6.83 hours per night, which is less, right? But remember, we can't just right now stop and say, we call BS and we reject your null hypothesis because our sample was smaller than your claim. No, we have to prove that the difference is statistically significant by going through our p-value process. Now, we're going to do this test at a significance level of 0.05. Okay, so let's do this. So right now we are ready to calculate our test statistic, which, as we mentioned, since we know sigma, is z. So here it is. The test statistic is this. It's our sampled mean minus mu over sigma over square root of n, right? We've seen that z-score before. So in our case, it's 6.83 minus 7 over sigma 1.99 over square root of 12. And so it turns out to be a negative 0.30 when I round it to 2 decimal places. Okay, we're going to, in the p-value approach, remember how this works? We need to find the p-value next, and in order to find the p-value, we start by drawing the picture. The mean, the claimed mean, is right there in the middle, 7. Our sample is right down here at 6.83. And so we need to find this area. This area right here is the p-value. Okay, it's a one-tailed test because the alternative is that we think the mean is less than 7. So we need to find this green area. So we know how we do it. Our boundary is at 6.83, which has a z-score of negative 0.30. Right? And so if we look that up in our table, a negative 0.30 as a negative z-score, negative 0.30, we get 3821. So this area is 0.3821, and that is our p-value. Okay, oops, 3821. And now remember what we do. Once you have your p-value, you compare your p-value to your significance level. So 0.3821 is definitely bigger than 0.05. And if our p-value is bigger than the significance level, we fail to reject the null, which is to say we can't say that they are wrong. Yes, our sample was smaller than 7, but that smallness, that difference from 7 of 6.83 is just likely. There's 38% chance that it's likely just due to chance, due to the 12 people we surveyed, right? So we can't reject. We don't have evidence to reject. So we fail to reject their null hypothesis. And so that's how we do a t-test, testing a claim about a mean when we know sigma. It's actually a little easier because we're working with z-scores, which we're very familiar with.